Ever catch yourself staring at a painting, like really feeling it, and wonder what's going on inside your head?
It's like your brain's throwing its own little art party in there.
Exactly. And get this, scientists are figuring out how to peek into that party using AI.
Wild, right. They're using this tech called EEG, basically a brainwave reader.
So instead of just guessing what people feel when they look at art, they can actually see it happening in their brains.
Exactly. In this study, they showed people different versions of the Mona Lisa.
I'm picturing like a disco Mona Lisa, all bright and colorful.
Not quite. They just tweaked the brightness, some brighter, some dimmer, and they tracked how people's brains reacted to each version.
Like, could they tell if someone was looking at a super bright Mona Lisa versus a dim one just from their brain waves?
You're on it. And hold on, they also did this with that optical illusion, the Necker cube. You know, the one that looks like it's flipping in on itself.
Oh yeah, that one messes with my brain every time.
Same here. But that's what makes it so perfect for this kind of research. They want to see how the brain handles tricky visuals.
So they're using both famous art and brain-bending illusions, all hooked up to this EEG brainwave reader. What did they find?
Well, their first try was shockingly accurate. They used this deep learning model, and it nailed the brightness level almost every time.
Sounds like a win. Right there.
Almost. See, sometimes being too perfect raises red flags.
How so?
Imagine acing a test because you memorized the answer sheet, not because you learned the material. That's what they wanted to rule out.
Ah, so the AI could have just been parroting back what it had seen before.
Exactly. That's why they didn't stop there. They designed a whole new approach to really put their findings to the test.
Okay, so round 2 of brainwave analysis, how'd they do?
They went all out, using a bunch of different models and fine-tuning techniques, like trying every tool in the shed to make sure they got it right.
Sounds intense. What were they hoping to learn from that?
Two things. Could they find a consistently reliable way to analyze this brain data? And which parts of the EEG recording were most important for figuring out the brightness? They wanted to pinpoint the aha moments of brain activity.
So it's not enough for the AI to just guess the brightness. They want to know why and how it's making that connection.
You got it. This is about more than just right or wrong answers. It's about understanding the language of our brains when we experience art.
So we've got AI decoding brainwaves, figuring out if you're looking at a bright or dim Mona Lisa. Pretty cool. But what else did they learn about how our brains react to this stuff?
Okay, so remember they used both the Mona Lisa and the Necker cube.
Right, the one that's like a box flipping in on itself.
Yeah, so get this, the brain reacts differently to each one.
Really? How so?
With the Mona Lisa, the right side of the brain was going wild.
Wait, the right side? Isn't that the creative side, like the artsy side?
Exactly. And that could mean that when we look at something visually interesting that we really want to dive into, our right hemisphere lights up.
Makes sense. I mean, the Mona Lisa, it's a simple portrait, but there's so much to notice. The smile, the background, you can't help but get lost in it.
It's not just seeing a face, it's processing all those tiny details that make it art.
And what about the Necker cube? What happened there?
With that one, when they focused on the left side of the brain,
The logical side.
yep, they found specific moments in the EEG data that were super important for figuring out the brightness.
Interesting. So with the mind-bending illusion, it's the logical left brain that's working overtime. Why is that?
It might be because the Necker cube takes more brain power to process. It's always changing, so your brain has to work harder to make sense of it. And we think the left hemisphere handles that kind of intense focus.
So it's like our brains don't just passively see. They're actively trying to solve these visual puzzles.
Totally. And this is just the beginning. We're just starting to understand how complex and adaptable our brains are, especially when it comes to art.
It's mind-blowing. If we can learn this much from just brightness, imagine what else is hidden in there. How we see beauty, emotion, the meaning of it all.
Right. What if AI could be the key to understanding all of that?
Now that would be incredible. So we've got AI telling us about bright Mona Lisas and busy left brains. But how does that help us understand something like beauty in art? How do we get there?
That's the big question, right? This study looked at brightness, just one tiny piece of how we see.
But if we can understand that one piece, could it unlock the rest? Like a domino effect.
Exactly. What if we could use the same tech to see how our brains react to something truly beautiful? A sunset, a sculpture, even music.
It'd be like looking into the soul of art, seeing how it makes us feel.
We might find patterns in the brain that only pop up when we experience beauty, no matter what kind of art it is.
So instead of saying, Beauty is in the eye of the beholder, which always felt like a cop-out.
Right.
We could actually see what's happening in the beholder's brain.
And that's where it gets really cool. Imagine seeing how our brains are wired differently based on our experiences, our culture. It all shapes how we see art.
It's like we're about to understand the human mind in a whole new way.
And maybe we'll find that our reactions to art are more similar than we think. Like there's some fundamental brain magic that happens when we connect with something beautiful, whether it's a masterpiece or a kid's drawing.
This whole thing has been amazing. It feels like we're just scratching the surface.
Oh, we are. This is just the beginning of something huge.
It makes you think what other mysteries are hiding in our own heads, just waiting for us to discover them. And, hey, maybe art is the key. Who knows? That's something to think about. This deep dive is a wrap. But keep those brains buzzing out there.